Guys! We have 1 hour to turn in this storyboard.
Oh my god, you're using the thing.
What?
You're holding graphite that could be the strongest material in the world.
No, it's not.
Let me explain.
Graphene was discovered in 2004 by Andrei Geim and Kostya Novoselov, which is not that long ago. Geim and Novoselov were looking to create something similar to carbon nanotubes, so they decided to polish down a block of graphite to 10 to 100 layers thick to study the material's properties. This initial idea was not achieved, but the ultimate goal was reached by using a piece of Scotch tape. I know, weird, right? The tape was used to peel layers off over and over again until flakes that were 10 layers thick were attached to the tape. Geim and Novoselov then dissolved the tape in solution to isolate the ultra-thin graphite. Refining this process then produced the first sheets of graphene. In 2010, the creators of graphene won the Nobel Prize in Physics for their amazing discovery. Graphene is considered two-dimensional, making it the thinnest and lightest material. It is only 1 atom thick and is composed of carbon atoms bonded together in a hexagonal shape. In addition to being thin and light, the material is also very conductive and flexible. The reasoning for graphene's strength is due to the covalent bonds associated with the carbon, which makes it very strong overall. Its high conductivity is due to its electrons moving much faster than usual in regular molecules, moving almost at the speed of light.
I'm here to ask some questions about the materials. So, to the best of your knowledge, what is the strongest material in the world right now?
Well, George, that's really a silly question because we both know the answer to that.
And
It's graphene.
Okay. Why is that?
Well, George, let me explain something to you, okay, buddy? You take a picture of graphene like this one. 1 second.
What is?
Like this one. And you can see those carbon covalently bond structures? That's good. We like that.
Let me further explain Professor Ben's statements about graphene structure. Graphene itself is very strong. However, when you take something such as graphite, which is many, many layers of graphene stacked on top of each other, they're easily broken. This is due to the weakness of the bonds holding the layers together compared to the carbon bonds within those individual layers.
Graphite can be found in an everyday item such as pencil lead. This graphite can be used to make graphene. As we stick the Scotch tape to the graphite over and over again, we are peeling layers of graphite off like an onion. We continue to peel layers off until we are down to 1 layer of graphite, which is referred to as graphene. This process is called mechanical exfoliation.
One problem with this method of obtaining graphene is that it is unsustainable at a production standpoint. In order to produce mass graphene, methods much more complicated and expensive, such as liquid phase exfoliation, are required. This method involves using graphite and placing it under a high-tension liquid and playing sounds strong enough to extract the graphene flakes. Not only is this rather complicated, but also does not produce as high-quality graphene.
Graphene has been used for a variety of fields ranging from optical electronics to photovoltaic cells and to biomedical engineering. Optical electronics deals with electronic devices for emitting, modulating, transmitting, and sensing light. To be a good fit for optoelectronic applications, a material must be able to transmit more than 90% of light. Graphene is a completely transparent material, is able to optically transmit up to 97.7% of light, and is also highly conductive. This is why it can be used in LCD touchscreens for smartphones and computers. Graphene's thinness and flexibility means that instead of having bulky batteries, we could have lighter and user-friendly batteries. Imagine if we could incorporate batteries into clothing that could instantly recharge your phone when you are exercising outside. Or we could even create retrofitted photovoltaic window screens or curtains to help power our homes.
Graphene is a material that has the best of all worlds. There is ongoing research in these various applications. However, like the saying goes, glitter is not always gold. There can always be a downside.
Its potential environmental risks of leaching into our water body have to be considered as well. As we all know, there's always a domino effect where once it enters our ecosystem, it will affect the food chain.
Although graphene is not fully understood yet, its capabilities are limitless, and it could make our world better, stronger, and faster.
We have 5 minutes left to submit this storyboard.
Wait, what?
Isn't it due to 4?
It's 3:55 right now.